Let me talk about a big question that a lot of people have with the diatomic elements. These are the diatomic elements here. There's 7 of them, and they're bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Now the diatomic elements are special because you never find just one atom of a diatomic element on its own. You always find them in pairs, okay? So you get Br2, I2, N2, and so forth. The big idea here is, say for oxygen gas, you never find just one oxygen atom floating around. You always find it paired up with another oxygen atom, making a molecule with 2 oxygen atoms, and that's O2, and that's what's floating around. Okay, so after you learn about the diatomic elements, it can be kind of confusing when you run into formulas for chemical compounds like these. Okay, all of these formulas contain diatomic elements, but there's only one atom of them. Okay, so here we have one oxygen atom, one chlorine atom, one nitrogen atom, one bromine atom. So can you see why this is kind of confusing? Because here they're in pairs, and here they're individual. Let me show you some comments I've gotten on my videos that express this confusion. Okay, one person asks, how can H2O only have one oxygen atom? I thought oxygen was a diatomic element, so you can't just have one. You always have to have 2, okay? Now talking about LiBr here, someone else asks, wait, shouldn't it be LiBr2? Because bromine is diatomic, so the atoms always need to come in pairs. So what's going on here? How come the diatomic elements, we say that they have to come in pairs, and then we write all these formulas where we only have one atom of a diatomic element? These are great questions. Let's talk about this. So here's a big thing that sometimes is like the missing piece for people's understanding with the diatomic elements. Atoms of diatomic elements only need to pair up if they're on their own and not connected to any other elements. Okay, so let me show you what I mean. Let's take nitrogen gas. Nitrogen gas is made of only nitrogen. So if we took a little sample of nitrogen gas and we zoomed in zillions and zillions of times to be able to see the atoms that make up nitrogen gas, we'd see that the atoms are connected together in pairs of 2, okay? This is what nitrogen gas would look like. This is what the atoms in nitrogen gas look like. We've got only nitrogen here. The nitrogen atoms are paired up. If we looked at nitrogen gas, we would not see something like this, where the nitrogen atoms would be floating around individually. Okay? The same is true for liquid bromine, which is made of only bromine. We zoom in on a tiny little drop of liquid bromine, and it looks like this. The Br atoms are connected together in pairs. It would not look like this with the Br atoms individual. Nitrogen and bromine have to pair up because these contain, nitrogen gas, liquid bromine, contain only this element. There's just nitrogen here, there's just bromine here, so the atoms have to pair up. But if diatomic elements are connected to other elements, they don't need to pair up, right? So that's how we can have H2O with just one oxygen atom, because this O, it's not connected just to another O, but it's connected to 2 hydrogens. That's totally fine. This chlorine here, we can have one of it because it's connected not just to chlorine, but to sodium as well, and that's true with these other ones. So the big deal with the diatomic elements, don't forget this, is that they only need to pair up if they're only connected to each other, all right? 2 nitrogens have to pair up, 2 bromines have to pair up, but if they're connecting to other elements, they don't need to be in pairs. So all of these chemical formulas are totally fine. If there's another element in there, don't worry about the pairing, only if that element is on its own.